Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello viewers, subscribers, students, and future engineers. Here is another set of problems in variations. These are very light, but for those who are fresh engineering students, you can improve yourselves by considering these problems. If you want to anticipate the solution, you may do so by pausing the video. Just consider the problems, then compare answers later. Give a statement about the variable on the left hand side in the language of variation. All letters except the constant k represent variables. So A, y equals 16x, B, u equals negative 5x cubed, Z, 7x, y to the fourth, D, w equals kx squared y, E, w equals ku over v squared, z k square root of y over square root of x, g u equals kx y to the 1/3 over vz to the 1/2, then w h w equals kx cube over yz cube. So the first one, this is the direct variation. Y is proportional to x, y varies as x, y is directly proportional to x. So those are the possible statement of 3a. So this is enough. Y is proportional to x. For part B, u is proportional to the cube of x, or u varies as x cube. The constant of proportionality is negative 5. U is directly proportional to x cube. So those are the possible statements for part B. For part Z, so we can say that Z varies jointly as x and y to the fourth. Z varies jointly as the product of x and the fourth power of y. So those are the possible statements. Then D, W varies jointly as y and the square of x, or vice versa. Then E, 3E, y varies directly as u and inversely as the square of v. So that's maybe the possible statement. So y varies directly as u and inversely as the square of v. Then z, f rather. So z varies as the square root of y and inversely as the square root of x. So that's the possible statement. You may have another statement for that as long as it agrees with that equation. Then 3g, u varies jointly as x and the cube root of y, or y raised to the power 1/3, and inversely as uh, d and z to the 1/2. Then h, w varies as the cube of x, or w is directly proportional to the cube of x, and inversely as y and the cube of z. Or the other way around, w varies as x cube and inversely as y and z cube. So that's it for that problem 3. We proceed to problem 4. By employing the data, obtain an equation relating variables with an explicit value for any associated constant which arises. So there are 4 problems in this part. So A, capital H is proportional to x cubed and H is 20 if x is 2. So in translating this to an equation, capital H is equal to constant times x cubed. So capital H equals constant times x cubed. Then let's evaluate the constant. H is 20 if x is 2. So 20 equals k times 2 cubed. So k is 2.5. Therefore, the equation is h equals 2.5 x cubed. For part B, W is inversely proportional to square root of y. So W equals, we have a constant of proportionality over square root of y. And that W is 10 if y is 9. So 10 equals k over square root of 9. Square root of 9 is 3 times 10. So k is 30. Therefore, the formula W equals 30 over square root of y. For C, z varies directly as x and y, and inversely as the square of u, and z is 30 when x is 5, y is 4, and u is 2. So that means z is equal to constant of proportionality times x times y, and divided by u square. So z kxy over u square. Z is 30 when x is 5, y is 4, then z is 2. So over 2 square, cancel 4 and 2 square. So 30 over 5 is 6, k is 6. Therefore, the equation is z equals constant xy over u square. So 6xy over u square. For the by employing the data same, so this is part 40, the last exercise for this part. B varies jointly as u and v and inversely as z and square root of w. So in equation, B is equal to constant of proportionality uv over z square root of w. So B is 24 when U is 3, V is 5, Z is 1 half, and W is 1 over 25. Substituting 24 equals K, X, U is 3, V is 5 over Z, which is 1 half, then square root of 1 over 25. 1 half times square root of 1 over 25 is 1 over 10. So we have 24 equals 15 over 1 over 10. This is 150. So 24 over 150 is equal to 4 over 25. K is 4 over 25. Therefore, B is 4 UV over 25 quantity 25 Z squared of W. Then problem 5, find the specified quantity by use of an equation of variation. So this time we determine the specified quantity in these problems. So if W is proportional to U and if W is 5 when U is 4, find W when U is 8. So the equation W proportional to U, so W equals KU. So when W is 5, U is 4, so 5 equals K times 4, so K is 5 over 4. So therefore, the formula is W equals 5 over 4 times U. Then we find W when U is 8. So 5 over 4 times U is 8. So 5 times 2, W is 10. Then part B, if V is inversely proportional to X and Y, and if V is 20 when X is 2 and Y is 8, find V when X is 4 and Y is 10. So this time, since we on this determine or find the specified quantity, we don't need to solve for the constant or define the equation. So I have this another solution so that we will no longer solve for the constant. So V is inversely, so constant of proportionality, proportional to X and Y. So V equals K over XY. That's why if we solve for K, it is VXY, then it is equal to V1 X1 Y1. So same expressions, same symbols and variables, we just put subscripts at the right side. The subscripts 1 would be that these quantities are specified in the initial conditions, then this would be the final conditions. In the final conditions, one of these symbols would be unknown. So V is the final, and these are the data in the final situation. So X is 4, Y is 10. So X 4, Y 10. Then in the initial, all these quantities are completely specified. So V is 20, X is 2, or X1 is 2, and Y1 is 8. So 20 to 8. So that 20 over 10 is 2, then 16 over 2 times 2 times 8 divided by 4 is 8. So V is 8. So that's it for this video.